Hello gentlemen, purpose of this video is to continue on looking at some of these special formulas that we are using to solve trig equations. This particular video is going to have to do with half angle formulas. So let's get started. And so we have a half angle formula for sine, cosine, and tangent. One thing to note, you can see that we have a square root here and we have the plus or minus part here. The plus or minus is going to depend upon which quadrant we're going to be in. And so we'll have to make use of the fact that if we're in quadrant 1, that both sine and cosine are positive. If we're in quadrant 2, sine is positive, cosine is negative. In quadrant 3, they're both negative. And in quadrant 4, sine is negative and cosine is positive. So we're going to have to make some determinations upon the appropriate sign, so that all will depend upon where u over 2 lies. So let's do a couple examples. I'm looking for sine of 3 pi over 8. And right off the bat, this isn't one of our known formulas from the unit circle. But I do note that I can rewrite sine 3 pi over 8 using a half angle. I can say that sine of 3 pi over 8, I can note that 3 pi over 8 is the same as 3 pi over 4, which I do know, over 2. And so I'm going to make use of that fact and then use a half angle formula. And so if I do that, all of a sudden I can use this half angle formula to rewrite this like this. Okay, and I know what the cosine of 3 pi over 4 is. That's in the third quadrant. Cosine is negative in the third quadrant, and it happens to be negative root 2 over 2. And so I can rewrite it like this. Okay, now I can get a common denominator there of 2. So I can write the top as 2 plus root 2 over 4. Okay, don't let the double roots here screw you up. Then I can pull that square root of 4 out and make it 1/2. And I can be right there. Okay, let's do another one like that. Tan of pi over 12. And again, just like I did above, I can write pi over 12 as pi over 6. And again, pi over 6 is one of the angles I do know, over 2. And so if I rewrite that like that, I can now use my half angle formula for tangent, and I'll get 1 minus cosine of pi over 6 over sine of pi over 6. We know the cosine of pi over 6 is root 3 over 2, and the sine of pi over 6 is 1/2. So I simplify down to there. Okay, I can keep simplifying a little bit. I can multiply by, get a common denominator here, and then multiply by the reciprocal. So you should see this 2 and this 1/2 are going to cancel, and I should get 2 minus root 3. Okay, let's do one more, but let's use it to solve an equation. This is actually a pretty good problem. So if I'm looking for all x on the interval 0 to 2 pi, I want to first get rid of that cosine of x over 2. And so I'm going to use my half angle formula right here. I got plus or minus 1 plus cosine x over 2 equals sine x, square root on this side. Let's square both sides. And because we're squaring both sides, we're going to have to check our solutions, see if we have extraneous solutions at the end. Well, if I do that, I get 1 plus cosine of x is equal over 2 is equal to sine squared of x. Now I can make some uses here because I want to get everything in terms of cosine. If I do that, I'll note that this is 1 minus cosine squared of x. So this term right here, using the Pythagorean identity, is right there. And I brought the 2 to the other side. And so what I'm going to do is get all the terms on one side and set it equal to 0, like I've done in the past. What you should notice at this point is that this is factorable. And so I can factor that. So I'm going to do that as 2 cosine x minus 1 and cosine x plus 1 is equal to 0. I set each one of them equal to 0 because either way that will be a solution. So where is cosine x equal to 1/2 on this interval? Again, we're going to be in quadrant number 1 and quadrant number 4. And so on this side, we're going to get pi over 3 and 5 pi over 3. Cosine x is equal to -1. That happens at pi, like that. And like I said at the beginning, we have to go back and we have to verify that each work. So let's do that now. Let's make sure that both of them work. If I plug in pi over 3 here, what I'm going to get is, I'm going to get my pen back. So plugging in pi over 3 will give me cosine of pi over 6 minus sine of pi over 3. We know that this is root 3 over 2. This is root 3 over 2. And so that does equal 0. So this does work right there. Let's look at 5 pi over 3. So let's erase that part. And this one. So if I do that, if I go cosine 5 pi over 3, this is going to be 5 pi over 6 now. Okay, and this is going to be 5 pi over 3. Well, cosine of 5 pi over 6, we know that that's in the second quadrant. This is negative root 3 over 2 minus 5 pi over 3 here. That's fourth quadrant. Sine is negative. Negative root 3 over 2. The negative and negative cancel, become positive, and again that's equal to 0. So that also works. So this one works and this one works. Last one is pi. So I'm going to get those two, cosine of pi over 2 minus sine of pi. We know cosine pi of 2 is 0. Sine of pi is 0. So that also works. So all three solutions here work. Okay? Here's some practice. I want you guys to read these pages, look at these particular examples. All of these examples, all these problems at the end of the chapter, end of the section, have to do with the half angle formula. They should give you some good practice. Okay? So if you have any questions, make sure you guys are emailing me. Again, there's a lot of formulas that we're going to use. We've got a couple more to do. Again, you don't have to memorize each formula, but you do need to know how to use them, so the practice is important. Okay? Have a good day, fellas.